So this is the final question, question 10 for the sample assessment material GCSE Edexcel 9 to 1 physics paper, higher tier. It's the hardest question in the paper apparently, but if you know your stuff, I don't think it is. Question 10 is, in a nuclear reactor, a chain reaction is produced and controlled. Uranium-235 is the isotope used in many nuclear reactors. Explain how the fission of uranium-235 can lead to a chain reaction. So when uranium-235, and you can write it like that, U235, splits, which is fission, so fission is a splitting of the atom, it releases 2 or 3, you can write either number, it depends on the reaction which one it's going to release, or you can write both, neutrons, which can cause further fission reactions as long as they are absorbed by other uranium-235 nuclei. This causes a chain reaction. So for fission to occur, a uranium-235 nuclei has to absorb a neutron. When it absorbs the neutron, it becomes unstable and splits into 2 smaller nuclei and a couple of neutrons. And then those neutrons can be absorbed by other uranium nuclei for the same thing to happen. So if that keeps happening, it's a chain reaction. Starting one off will cause the rest of them to happen. Nuclei of beryllium-9 do not absorb neutrons. Instead, nuclei of beryllium-9 absorb alpha particles and emit neutrons. Give a reason why a chain reaction can result from the emission of neutrons by uranium nuclei, but not by beryllium nuclei. Now, for the chain reaction to happen, the particle that is absorbed must be the same as the particle that is emitted. So it's the neutrons emitted from the fizzed uranium nuclei can then cause more uranium nuclei to fizz, whereas that's not going to be the case here in beryllium because beryllium just won't absorb it. Explain what happens. You can see some spelling mistakes here, grammar mistakes. Explain what happens inside a nuclear reactor if neutron speeds are not controlled. So people will assume it'll just turn into a nuclear bomb. Not true. Fission requires slow neutrons. So when a uranium atom absorbs a neutron to then split, that neutron needs to be going quite slowly. If it's going too fast, it'll just go straight through and won't be absorbed. So fission requires slow neutrons. The neutrons released in fission are too fast to be absorbed by other U235 nuclei. So if not controlled, they won't cause further reactions. Therefore, the rate of reaction will slow or stop completely. Apologies for my quite bad handwriting. And then finally, part C, describe how the energy released in chain reactions in a nuclear reactor is used to drive a turbine in the nuclear power station. So the reactor is surrounded by a coolant, usually water, but it could be something else, so a coolant, which heats up due to the fission reactions. This coolant is used to boil water to produce steam, which drives the turbine. Now, you'd be forgiven for thinking that this because the coolant could be water, you'll just use that water to boil, but not the case. Because of contamination and radioactivity, they keep the coolant, or the water that is the coolant, separate to the water that is the boiling water. So here is an example from a textbook. You can see we've got two separate systems. So this is the reactor with the coolant, such as the water, and then here is the water that boils, and they're not actually touching. They're in two separate systems because this is the radioactive water, and this water won't be radioactive. So they want to keep them separate. So there we go. That is the end of that paper. Hopefully it wasn't too terrible.